Okay guys, we are learning about the area of rectangles and parallelograms today. So to complete this lesson, you will need this handout that says Thursday, April 18th on it, and you will also need your reference material chart that is in your composition book. So if you can have that handy, that will be helpful. Alright, make sure you put your name and class where you top of your paper before we get started. Alright, so area you guys have learned about before. Area is the surface measurement of a two-dimensional figure. So it means that if we're looking at a playground or a field or a tabletop, we are simply measuring the surface measurement of it. Not how deep it is, but just the surface measurement of it. We will use the formula A equals BH. The A is a capital letter and B and H are lowercase letters. In this case, where B is the length of the rectangle and H is the height of the rectangle. Now, you may also see this written as area equals length times width instead of base times height. B technically stands for base instead of length, but it still means the same thing. So it means that you're looking at the base or the bottom part of a rectangle and also the height of that rectangle, or we can call this length and width, but it means the same thing. You will need two measurements of a rectangle to be able to find the area. It's important to note that area is measured in square units. Now, just like when we were learning about exponents, I told you guys that to find the area of a square, you would multiply the same side by the same side. So in this rectangle 3 that you see here, that would have been 4 times 4 because this is a square. Well, since it's 4 times 4, instead of repeating that multiplication of 4 times 4, they relabeled it as 4 squared because it seemed to only happen when we were finding the area of squares. So when we find the area of a square, we are multiplying not only that number times that number, but the units times the units. So if you're finding the area of a rectangle or a square and it is inches times inches, then your answer would have the units inches squared attached to that. And inches squared simply has the abbreviation for inches with the exponent of 2 attached to that. If it was feet times feet, that would be feet squared. So the abbreviation for feet with the exponent of 2 attached to that. If it was meters times meters, it would be m with an exponent of 2 attached to that. So meters squared. Now, if you notice on your reference materials, area is here, and we're looking at rectangles or parallelograms today. So it says that area equals base times height or area equals length times width. It's important to note that B stands for base and H stands for height. And we will technically use base and height when we're talking about parallelograms and more length and width when we're looking at rectangles. But as long as you know you need two measurements to find the area of both of those, will be okay today. Okay. So rectangle 1, if I look at this picture of rectangle 1, I could easily just count the squares that are inside of this rectangle to figure out the area of that. But that would take a lot of time, and I don't always have all these little squares to count. So instead of counting the squares, I'm simply going to multiply the base times the height or the length times the width. So if you've noticed, I have labeled these. This has 7 as the units here and 5 as the units here. Well, if my formula is area equals base times height, to solve this, I simply plug in the values of my base and my height. Now, plug in simply means substitute. And we learned about that when we were doing equations and inequalities. So that simply means that we are taking the letters and replacing them with numbers. So we're substituting numbers in place of letters. That can also be called plug in. You're plugging in a number in place of the letter. So in this case, to find the area, I would take the base out and put a 5 in place of that. And I would take the H out and put a 7 in place of that. So area is equal to 5 times 7. So the area of this rectangle would be 35. And since they didn't tell me if this was inches or meters or feet, I don't have those units, then I just simply use the word units. So the area here would be 35 units squared because I multiplied 5 units times 7 units. 5 times 7 is 35, and units times units is units squared. So that repetition of the multiplication gives me that exponent there. Okay, now that you know that, pause this video and do the area for rectangle 2 and 3, and then start it again to check your answers. Okay, so on this one, we would have plugged in or substituted 9 times 6 or 6 times 9. So the area would have been 54 units squared. And this was a square, so this one was easy to figure out that it had the same side times the same side. So when I plug in the values here, I have 4 times 4, which is 16 units squared. Again, if you wanted to check yourself, you could count those individual squares, but that's not necessary if you know that this formula simply means to multiply base times height. All right, number 4 and number 5 use decimal numbers and fractions. So instead of me just figuring out whole number areas, I can also figure out things that have decimals and fractions. So we're going to practice multiplying those items also. All right, so on number 4, we have 8 6 times 3 centimeters. So we have centimeters times centimeters. So I know the units on this will be centimeters squared because I'm multiplying centimeters times centimeters. But what I want to see here is what will happen when I multiply a decimal number times a whole number. When it says plug in the values, again, that means substitute. So I'm substituting what I know about this rectangle in for that formula. So area is equal to 8 6 times 3. And I would set that up as a multiplication problem. Now, when you're setting up multiplication problems, the number with the longest amount of digits or the most amount of digits is the one that goes on top. So since 8 6 has more digits, when I set this up as a multiplication problem, that would go on top. So 8 6 times 3. 3 times 6 is 18. Carry the 1. 3 times 8 is 24 plus the 1. That gives 258. However, there is one digit behind the decimal in this multiplication problem, so there is one digit behind the decimal in my product. So the area of this rectangle is actually 25 8/10, and then it was centimeters times centimeters, so that's a centimeters squared. Now, if you're curious about why that happens, let me show you that. What we took here was centimeters times centimeters. And instead of me writing centimeters times centimeters behind each one of these answers, I do what we do with exponents, and I just put the exponent of 2 there to show that there was 2 of those written down multiplied together. So that's centimeters squared. Number 5 uses fractions. So when we are multiplying fractions, we sang that little song, multiplying fractions, that's no problem. It's the top times the top and the bottom times the bottom. But we're given mixed numbers. To show that this is mixed numbers, we have to first change these mixed numbers into improper fractions. So if you don't remember how to do that, I'm going to show you that right here. So we have 1 1/2. And to do that, we're going to do the MAD method. And if you remember the MAD method, that means you take the denominator and multiply it by the whole number. That's where the M in the MAD method comes from. Then you add the numerator, that's the A in the MAD method, and you keep the same denominator. That's the D for MAD. So I'm going to multiply 2 times 1, add 1, which gives me 3/2. Okay. I'm going to take the other mixed number, 2 1/4, and do the exact same thing. I'm going to use the MAD method. So 4 times 2 plus 1 gives me 9/4. Then I'm going to multiply those two together. I'm simply multiplying 3/2 times 9/4. Now, as a reminder, anytime you're multiplying a fraction times a fraction, it is important for you to check to see if you can cross cancel. If I can, that usually will save me a lot of trouble so that I don't have to simplify so much in the end. So we always want to check to see that. Now, cross canceling means you look diagonally at this digit and this digit, and you're determining if they share any factors that they both could be divided by. Well, 3/4, they do not share any factors. 3 is prime and 4 has factors of 2 and 4, so that can't be simplified. If I look at 9 and 2, 2 is the prime number. It can only be divided by 2, and 9 can only be divided by 3 and 9, so that can't be simplified either. So instead, I just multiply the top times the top and the bottom times the bottom. So 3 times 9 is 27, and 4 times 2 is 8, which gives me an improper fraction. But I don't want to leave my answer in an improper fraction. So instead, I have to You got it. Do top in, bottom out. So I have to do 27 divided by 8. Take the time to do that and then check your answer in just a second. You can pause the video if you need to. Okay, so now I divide that. 8 will go into 27 3 times. And 3 times 8 is 24. 27 minus 24 gives me a remainder of 3. I can stop at this point and use these numbers to form a mixed number in my answer. So when I solved this problem, my plug-in values were the two values of that rectangle. So this meant that area was equal to 1 1/2 times 2 1/4. I changed those to improper fractions, multiplied them, and then divided to get a mixed number since that was an improper fraction. The area of the rectangle would be 3 and 3 over 8. This becomes your whole number. This is your numerator, and this 8 is your denominator from the original fraction we multiplied here. So the answer here is 3 and 3/8, and then I look for my units. This was feet times feet, so my units are feet squared. So area will always have units of squared, so feet squared or inches squared or meters squared. You're always looking for that exponent of 2. So that's how you find the area of rectangles. Now, since we can find the area of rectangles, that means we can also use the area, if we know the area, to find other parts of that rectangle. For example, if I know that the area is a certain amount and I also know the base, then I could use that to find the height. So let me show you what that looks like. If I have area equals base times height, and I already knew the area and I already knew the base, then I could divide by the base here to find the height. Because when I divide BH, or B times H divided by B, I know these are letters, so don't let that trick you. They work the same as numbers. When you have B divided by B, that's just like having a number divided by the same number, like 3 divided by 3 or 4 divided by 4. Those cancel out and become 1. So when that cancels out and becomes 1, that means that H, or the height, is equal to the area divided by the base. So if I already know the area, then I can divide by the base to find the height. Well, the same thing is true if I already know the height. So if I already know the height, then I can divide by the height to find the base. And again, letters work just like numbers. So H divided by H is 1, just like 4 divided by 4 would be 1, or 5 divided by 5 would be 1. And I'm left with the B for base. So base is equal to the area divided by the height. So when it's writing formulas that can be manipulated, manipulated simply means changed. I can change them around and move them around however I want to find missing information. So the two equations or formulas that we're going to use here is H is equal to area divided by the base. So if I want to find the height, I would take the area and divide it by the base. And base is equal to area divided by height. So if I want to find the base and I already know the area, I can just divide by the height to find the base. Okay, so let's use that on the next examples. Flip back to this page at any time that you need to look at this, and pause the video anytime you need to so that you understand. If you're confused during class today, please ask Ms. Pineda to help you and she can come around and do that. Okay, so on number 6, I have been shown a rectangle, and in this particular rectangle, I already know the area. So it tells me that the area of this rectangle is 162 meters squared. Again, the units are squared because I'm talking about meters times meters here. So I already know that these meters are squared. Okay, so I'm going to write this on the inside of this rectangle. Area is equal to 162 meters squared. And I'm trying to find the base, which means I already know the height and I already know this. Well, if base times height gives me this, then I do the inverse operation of multiplication, which is division. So I'm going to take the area that I would have found by multiplying and divide by one of the numbers that I know to find the missing number. So the formula that we use here is base is equal to area divided by height. So I'm going to find the base by taking this area, that's 162, and dividing it by this height of 18. So 162 over 18, which means that I'm doing top in, bottom out division. Okay, pause the video and do your top and bottom out division and then check to see if you got the same answer that I did. Now that you have done that, we're going to check to see if we have the right answer. I assume that most of you have 18 times some stuff written over to the side over here. So one of the things that I usually try first is 18 times 5 just to see where that lands, so I know if I need to increase my number or decrease my number. And 18 times 5 in this case was 90, so that means that I would have to increase that quite a bit. So I hope you guys tried something like 18 times 8 next to see how that would land. So I should see some of this work over here on the side. 8 times 8 is 4, carry your 6, and that would have given me 144. And I imagine most of you tried 18 times 9 also just to see how that worked. And 9 times 8 is 72, carry your 7, and then that gives me 162. So that worked perfectly. So 18 will go into 162 9 times, and 9 times 18 again is 162. So the answer that you should have gotten here was 9. But I have to figure out what the units are. Well, when I find area, units are meters squared. But I found area by multiplying meters times meters. So the base would have been given to me originally in just meters, not meters squared. So if you're just finding the base or the height, you would just want meters or feet or inches. But if you're finding area, you would want those things squared. So be careful of that. You only need those things with the exponent of 2 if you're finding the area. If you're just finding the measure of one of the sides, it's simply that unit. So meters or feet or inches. All right, so number 7 is talking about these formulas that we can manipulate to find other things. So it says circle all of the formulas below that could be used to find the height of a rectangle with a base of 11 and an area of 120. Well, in this particular problem, I'm given the base and I'm given the area, but I'm trying to find the height. Well, if you flip back and look at the thing that we wrote down at the bottom of our other page, h was equal to area divided by base. So I'm supposed to circle all of these that I think would represent that. So one of the things that jumps out to me is the ones that say h equal. Well, E says h equals 11 divided by 120. Well, that's not area divided by base. That's base divided by area. Well, I don't want to do that, so that can't be one of them. The other one that jumps out to me is this one that has h equals. So h equals 120 divided by 11. Well, that's the area, and that's the base. So yes, this one is one of them. But you'll notice it says circle all of the formulas. That clues me in that there's probably another one I could use to do this. So let's go back and think about our original formula. Area equals base times height. Does any of these represent that original formula where area equals base times height? So let's look at each one individually. A says 120 equals 11 times 11. Well, 120 is the area, but 11 represented the base. So that was base times base. Well, I didn't want base times base. I wanted base times height. C says 120 equals 11 times h. Well, 120 is the area, 11 is the base, and I'm looking for the height. So that one would work also. That fits my original area formula. So this would work. B says 11 is equal to 120 times h. Well, that means the base is equal to the area times the height. Would I take the area and multiply it by the height? No, I don't think so. Because base times height gives you the area. You would have to divide by one of those to find the missing side. So that one's not going to work either. So that one's just C and D. Alright, so that is rectangles. So now let's look at these other shapes called parallelograms. And these are some fun little shapes. The interesting thing about parallelograms is it's like somebody took a rectangle and pushed it from the side, and they pushed it so hard that they made it lean over. So it's almost like the Leaning Tower of Pisa, but it's the leaning rectangle that became a parallelogram. So we use the same formula to find a parallelogram as we do a rectangle, because that's pretty much what happened to a parallelogram, is it was a rectangle that got shoved over. So the dimensions of a parallelogram are also referred to as the base and height. So we will use that same formula, area equals base times height, or A equals BH, where B is the length of the base and h is the height of the parallelogram. Now it's important to notice that this has to make a particular form when I'm finding the height. So this has to make a right angle with the base. So let me show you what I mean by that. If you look at the pictures below, these two are parallelograms, this one's a rectangle. So let's look at these two. The height of it has to form a right angle with the base of that parallelogram. So you'll notice where these dotted lines are drawn, that is the height of the parallelogram. These things on the end are called slants. Well, I don't want to use the slant height as the height of this. I want to use the actual height, which is called the distance between the two bases. So we're going to make a note of that. H, or height, is actually the distance between, and we can abbreviate between two bases. Height is the distance between two bases. So this is a base here, and this is a base here. My height would be the distance between those two, but it would not be this slant height. I would not use that to find my area. So that's important to note. Also, this picture was drawn as a rectangle on purpose to show you something very specific. Remember how I said rectangles could be shoved really hard so that they're slanted to one side to make a parallelogram? Well, that's what's going to happen here. We're going to push this rectangle so that it looks like a parallelogram, which actually means I'm taking this part of this rectangle and actually moving it over to this side so that I'm creating a rectangle over here. So I want you to draw this on here also. We have picked up this rectangle and moved it over here to this side. So that rectangle is not there anymore. So if you kind of hide that with your finger, I have created a parallelogram that looks like this. That means that this piece right here has actually now created the height, or the distance between the two bases of this parallelogram. So if this top part is 6, then this bottom part down here would also be 6. So this is a base of 6 and a base of 6, and the height here would be 4, which matches the height here. And since I just picked this up and moved it over here, that's the distance between the two bases. So this part is gone now. It has been replaced on the other end of this to form this parallelogram instead of a rectangle. That is why we can use the same formula for the rectangle and the parallelogram, because it's just like a rectangle had a triangle cut off the end and moved to the other end to form a new shape. So in this particular parallelogram, I would area equals base times height. If I substitute or plug in those numbers, area is equal to 6 times 4, which means that the area is 24 units squared. Don't forget when you're finding area that you have to put the exponent of 2 at the end of that. Okay, pause this video and I want you to find the area of the next two shapes. Okay, now that you've done that, if I'm looking at this particular parallelogram, was this information right here important? No, this was the slant height. I don't need the slant height. I need the base, and I need this height, which is the distance between the two bases. So when I plugged in or substituted my values here, this would have been area equals 9 times 4. And 9 times 4 is 36, and this was given to me in centimeters, so that's centimeters times centimeters, so that would have been 36 centimeters squared. Okay, this one was a little more difficult. You had a mixed number and a whole number, so when you plugged in your values, this would have been a equals 2 times 1 1/3. Again, you would have to change 1 1/3 into an improper fraction, which is 4/3. So this would have been 2 over 1 times 4 over 3. I would have checked to see if I could cross cancel, which I could not. So this would have given me 8 over 3. But 8 over 3 is an improper fraction, so we would have had to have done top and bottom out. And we would have been left with 2 2/3. So if you ended up with 2 2/3 feet squared, then you worked that out correctly. Now, the last thing we're going to do in this lesson before you work on your own is look at what this says here. It says describe how the area of a rectangle and the area of a parallelogram with the same dimensions are related. So please keep in mind this picture right here. I cut off this triangle and moved it to the other end of this to form a new shape, and that new shape was a parallelogram. So how do you think the area of a rectangle and the area of a parallelogram are related? Before you move on to your homework, I want you to write one sentence that explains that for you. Okay, on your homework assignment that's on the next page, this is due Tuesday when you come back, so work on it today in class, and then whatever you don't finish is homework, and it is due Tuesday when you return to school. Please remember to use the formulas provided to you. On number 5 and 6, the direction says to read each question, sketch a picture, and solve for the area. So make sure on number 5 that you read that this is a rectangular shaped window, so I do expect you to draw a rectangle. And on number 6, this is a parallelogram, so I do expect you to draw a parallelogram. Make sure when you're finished drawing and answering that you use square units for that. So if this is inches times inches, that would be inches squared. If this is meters times meters, that would be meters squared. So please don't forget to put units on your answers. These 6 questions are due when you come to class on Tuesday. If you need additional help, I have posted additional videos on Google Classroom, and Miss Pineda is there to help you. Good luck, guys. I'll see you next week.